Hello, today we're going to be talking about a technique called mass spectrometry imaging. So you know how if you slice a strawberry from stem to tip, you can see that there's more red towards the outside of the fruit and less in the center? Well, this is what it looks like when you create an image of a certain anthocyanin, which is a pigment in fruits, in a strawberry sample using mass spectrometry imaging. First, let's talk about mass spectrometry. This is what a basic mass spectrometer looks like. There are different types of mass spectrometry, but today I'll talk about matrix-assisted laser desorption ionization time-of-flight mass spectrometry. In this technique, a matrix is added to the sample to help absorb some of the laser energy and help the sample ionize. First, a laser generates heat and bombards a spot on the sample with high-energy electrons. The laser ionizes the atoms in the sample and vaporizes the analyte and matrix mixture. Then the ions travel down a time-of-flight chamber. Because all the ions have the same kinetic energy, ions with more mass will travel more slowly and will take more time to reach the detector at the other end. Because ions with different masses will reach the detector at different times, the instrument can detect which ions are present and measure how much of each one there is. The data that is collected is called a mass spectrum. In the mass spectrum, the data is plotted on a graph, with the different masses on the x-axis and the abundance or intensity of each one on the y-axis. Mass spectrometry imaging uses mass spectrometry to create images that show where the different compounds are in a slice of tissue and how much is in each spot. The first step is to prepare the sample by slicing frozen tissue using a machine called a cryostat, and then mounting the sample onto a glass slide. Depending on what we're looking for and what kind of sample we're using, we might have to treat the tissue by doing things like washing or adding an enzyme to help release certain molecules. Then we apply a matrix, which is a substance like DHB or CHCA. It helps the sample to be ionized and detected. We can apply matrix either as a wet solution with an airbrush or automatic sprayer, or as a dry powder via sublimation. Then we insert the sample slide into the machine and use the software to test and set parameters. When we run the instrument, a pulsed laser scans over the sample, acquiring an individual mass spectrum for each little spot on the area. After that, we can use the raw data to generate images in several different ways using another software application. Here's an example of a software application that's used to analyze the data and to generate images. And these are some final images that show the distribution of certain lipids in mouse brains. Each image is for a specific lipid that has a certain mass. The areas of red are the areas in the brain where that lipid is most concentrated. Thank you so much for watching, and I encourage you to learn more by checking out some of these sources.